Okay, today is about inverses. All right, and inverses are a big flip between your x becomes your y and your y becomes your x. And your domain becomes your range and your range becomes your domain. So here's a function. I've got it graphed here. It's 4 to the right. Does that look like the right function to you? All right, let's figure out its domain and range. Would you please write down the domain and range for my little function here? Just doing it from the picture is so much easier, I think, than trying to solve it from the equation. All right, domain is from left to right, and so it starts working right here, which is what? And then it goes to what? 4 to infinity. And what did I just do wrong? Slightly, but wrong. Yes, sir. Bracket on the 4. Good, because 4 actually works in this function. The square root of 0 is totally okay. All right, then range is from how low to how high, and it goes like from this to this. So what is it? 0 to infinity. Can it be 0? Yes, it touches at 0. Okay, so there's my domain and range. Now, if I do the inverse of this function, then every single point on it can be reversed. So like, for instance, this spot right here, which is what comma what? Think now. It's 4, 0. 4, 0 becomes 0, 4. 0, 4 is like up here. Okay. And then what's another point that's on the square root function? I go over 1 and up 1, right? So tell me, what's another spot here right there? 5, comma 1. Good. And so what do we know is on the other function? 1, comma 5. Over 1, up 5. Like there. Do you see where this thing's going to go? I can see it. Let's do one more. If I do stick in a 4 into this function, no, not a 4, an 8 into this function, it's going to work pretty nice. Because it'll be comma 2. Okay, 8, comma 2, over 8, up 2. Instead, it's going to be over 2, up 8. All right. Now, I did not graph this on graph paper, so I'm a little bit off in how steep my slope was supposed to be. This thing shouldn't be rising quite so much. I better tone it down a little bit. It's more like that. All right, and then this one goes up like that. Those are inverses of each other. Now, I'll show you the real kicker. They are an exact reflection across the line that, which is called the identity function. It's one of your big 12. Remember, it's equation y equals x. Y equals x. It's one of the big ones. Right? These are our reflections straight across. So in other words, if I draw a straight line right through there, right through that line, perfectly perpendicular to that, it would touch. So this one at 1, 2, 3, 4, right there, straight through, it's going to touch that one. Those are inverses. Okay, so if I had just given you this equation and had not even given you the graph of it, you could have done all the things I just did and figured out where this function is by using a 3-step process of creating an inverse. And that's what I'm about to tell you next. But is somebody really struggling to stay awake? I want everybody to stand up. Everybody stand up. Stand up. Stand up. Stand up. All right, cool. Now you can sit back down, except for Graham. All right, thank you. Good. Now, hopefully that person is awake. Okay, so I would like to see if you can create an inverse algebraically. But before I do that, I just want to finish one last thing. This was the domain, or sorry, this was the function f of x. What do we call this thing? It's the inverse of f of x, but do you know how to do that? Yes. And the question really is it to the little -1 or is it with a little dash? Is it this or is it this? All right, I'm going to pause for a second. Do you see it on this screen, on the very first screen? Yeah, it's a little -1. Okay? So that's an inverse if it has the f to the -1. That's an inverse. Not that. Okay. So now, something else. Stay focused. We got a lot to learn. Okay, so this is, let me think, a reflection across the line. That's an inverse. And I've got my domain and range for my original function, which maybe I should write that one in black, f of x. And my new function I made in green here is f -1, inverse of x. This guy's domain and range are different. Think about it. Would you please write down what you think the domain and range are? If you're catching my drift, you should know the answer already. What are the domain and range of the inverse? Yes, you can just do it right from the picture, but there's an easier way. Yes, sir. Yeah. If you're swapping x and y, 5, 1 becomes 1, 5, then you can swap the domain and range. Domain is whatever the range was, right here, from 0 to infinity. And that also bears out from the picture I drew. You can see it starts at 0 and it goes to the right. So it's going to be from 0 to infinity, like to the right, meaning that way. So then the range is the same thing that domain was, right there. So range is 4 to infinity. Okay. Last thing is, can I show you all on one slide 2 days worth of material? I think I can. Okay, so this last thing I got to show you here is that this is a function, and I can make its inverse with a 3-step process. I can write the equation for the inverse. See, right now I've got this f -1 of x, but I haven't actually got an equation for it. You can't just switch x and y around. It'd be really neato if you could. If you could just say, oh, x equals square root of y minus 4. You can't. You're close, though. It's very close to that. See if you can pull the trigger. Why is that not going to work right here? That equals, and I can't put that in there. Think. Okay. What should I put right after that equal sign? Yes, sir. Nope. You would think to the -1 power would mean just put 1 over it. Doesn't work. This is kind of right. It's just not exactly right. Okay, how about this? What's the red one solved for? What's the black one solved for? And if I'm going to say f of x, then f of x is the same thing as y, isn't it? So I got to solve this thing for y, because right now I'm saying y equals, and then I can't put that. So bottom line, all you have to do is switch the x and y around and then solve for y. Because once I got this thing solved for y, and it'll be y equals blah, 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 that's what I can put here. Because this is like a y equals. That makes sense? So all I got to do is solve for y. How do I solve this for y? I start by squaring both sides. Now, some people get this all twisted in their head with that other kind where you square root both sides. You need the absolute values. We are squaring both sides. That doesn't cause that problem. I can square both sides. Not a big deal. Square this, square this. And x squared becomes just x squared. And then square root of this does just simply remove. Square root and squared cancel each other out very nicely. So it's just y equals 4, and it's almost solved for y. What do I got to do now? Add 4. And now I have x squared plus 4. Y equals x squared plus 4. So f of x equals x squared plus 4. Now I'd like you to look at the beginning and the end. We started with this little function right here, square root of x minus 4. Do you get that this is kind of an inverse operation? It's got a squared in it. Its inverse doesn't use square root. It uses squared. And this one subtracted 4, and this one adds 4. See how those are all kind of inverses of each other? All right, I'm hoping you can see how this kind of fits together on many different levels. All right, I'd like you to see if you could handle this one. Just picture-wise. What would that one, if you're going to reflect it over the line y equals x? Yes, got an answer or a question? Yes? Good question. Domain and range. Okay, so we already did specify that. The domain and range I erased, but this was the domain and range of the original. Remember how we reversed those? So we already had the domain and range written out. Are you saying you want to write the domain and the range after every time you're writing a function? That'd be good. But what you're saying is the domain. Enough. Not going to tell you more about that. Okay, so this one right here. Would you please see if you can figure out what the equation is for it in the first place, which isn't too tough. And then figure out what the inverse of it would be. When you flip it across that line, you reflect every point across that line. Would you sketch what you think comes out? Compare it with the kid to the left or right of you. I'll have to make, in this case, we're going to go, you're just comparing with her. And then you're going to go diagonal. Paying attention? You're going diagonal. You're going diagonal. And you two are going diagonal. Okay? Yep, finding the inverse of this. Oh, it's not impossible. I gotcha. But once you figure it out, you'll be like, oh, I totally get this now. All right. Would you agree that this is f of x, which is x squared or something like x squared? Does that make sense? And then, if you're good at flipping these things in your head, which I know some of you are going to be and some of you are not, let's take just this little part. You will see that it becomes that. Do you get how I flipped that across that line? And then it ends up being like that, which, do you remember that equation? X equals what? Y squared. And then, is that solved all the way? No, we're supposed to solve it for y. And then when we solve it for y, you get square root and square root, you'll end up with the square root of x equals absolute value of y. Yes, that absolutely matters because I have to have two answers for it then. Y equals positive the square root of x. That's the top of the little parabola thingy like that. And then the bottom part is going to be the reflection of that, which is on the bottom part, which is y equals negative square root of x. All right, now, I may have tried to teach you too much at once there, but we'll see. The domain and range of the original one, the blue one, the domain and range of the blue one. Would you please figure those out? That's an easy question. The blue one's domain and range. And then in a moment, you can just reverse them, and you'll know the domain and range of our new function. Yes, sir? Okay. I get you that we don't know exactly what those points are. You're right. Yep. All right, domain on this guy from left to right, which is negative infinity to positive infinity, right? The range, how low to how high? 0 to infinity. Does it touch 0 or not? Bracket. Okay, good. Then, it's so easy then to write the domain and range of this new one. You can just reverse them. But here's the catch. The new one's not a function. All right. So the vertical line test, you're right, would fail. Now, there's only a very small subset of functions. I shouldn't say it that way because there's actually an infinite number of them. But most functions you draw are not going to pass both the vertical and the horizontal line test. But some will. And if they pass the vertical and the horizontal line test, I'm saving that for tomorrow. That's just a special kind of function where its inverse is also a function. You might think that most functions, when you flip them across that line, are going to turn into something that fails the vertical line test. But some of them, they're a function in first place. And when you do their inverse, which, by the way, remember, looks like this. Oops, negative 1 goes on the F. Sorry. When you do its inverse, their inverse is also a function, and that's called a one-to-one function. But we'll save that for tomorrow. All right, your homework. I'm sorry I didn't hear that question. Let me get to the assignment first, and then you can ask a question. I'm afraid it might confuse either me or the rest of the kids, so I'm going to wait on that. All right, that's a review. These are all review problems from last night's homework. So now I'm getting to, there we go. Nope. First homework problem, where are you? There it is. Put all the ideas together problems. That, I sometimes add pages to mine, so I don't want to trust it. On yours, it's page what? Page 15 of the notes, apparently? Yes? Just hold on. Is it page 10? Okay. He probably added a page or two or something. Okay, as long as it's it sounds like it's page 10. Is this one, is the next problem this, with the puzzle pieces? Okay, good. Then that's where we're supposed to be. And these are our problems for tonight. So let's do one before we leave here. Yes?
It says that the exercise can start a couple pages down.
Okay, let me look. Yeah, you do have a point there. Okay. I think these put it all together are like important too. So, all right, how about this? We're going to do problem number 1 here of the put it all together type question. Put all the ideas together problems. All right. And we're also going to do, you know, I'm just going to trust that I know we can do number 1. And then we are going to do this page, which is going to ask you to show the given function is a one-to-one. Nope, we're not doing those because one-to-one is something that we're not teaching till tomorrow. So let me see if we can do more of this yet. All right. Yeah, that's too much for one day. So I am going to assign you problems 1, 2, 3, and 4, and let's make sure that we can actually do all of these. Let's do number 1 together right now. Find g of f of x. Okay, that's really easy. And if I write it this way, it'll be even easier. That's my suggestion on how to start. And you're going to make the g function swallow the f function. So I start with the g function. That's the g function. And I'm going to drop into its stomach an f function, which is that. All I have to do is simplify that out, and I'll have it. Okay. Now, write down the inverse of the g function. Okay, well, here's the g function. And that's like y equals x plus 3. You know that little 3-step process that I taught you? I'm going to show it to you again right now to do this. Inverse of g means I reverse x and y. So this becomes x equals y plus 3. Why can't you just write that? Because you have to solve for y. And y equals x minus 3. There we go. And now find f of the inverse of g of 5. Well, this is the inverse of g. So I'm going to label it that. G prime of, not prime, sorry, g to the negative 1, that's a different thing, of x is, no, of 5, there we go. That's what I want to figure out first, and then I want to do f of that. So now, I'm going to go and take this 5, stick it in that function, and now I'll have f of 5 minus 3, which is 2. And now it became really simple all of a sudden. Once I figured out the inverse g of 5, now I just have to do f of that. Okay, so these are all, I believe, all going to be doable. 1, 2, 3, and 4 is your only homework for tonight. Question? What? Page what?
It looks like a weird, like, kind of like a
Problem 3? What problem number?
problem number 2.
Problem number 2. Okay, the big R. That means all real numbers. The thing next to it, that means element of. That just means X is an element of the real numbers. What does that mean? All real numbers, like from negative infinity to positive infinity. Okay. All right, we'll learn more tomorrow. And that's all I have for you for today on inverses.